Welcome everyone to my LeetCode weekly contest 400 live stream. If you're here for solutions, jump ahead to 90 minutes in or use timestamps in the video description. In a few moments, we'll be doing the contest live, we'll be answering questions in the chat, we'll be giving hints, small hints, so come join us every weekend for the contest. No code will ever be shared during the contest. But after the contest ends, we'll go through the answers for all 4 questions, so make sure you stick around for the answers. If you enjoy LeetCode content, as usual, do check out the rest of my channel. I have videos on different problems, easy, medium, and hard, as well as the hardest question 4s of previous contests. And as usual, like and subscribe to stay up to date on new videos. Alrighty, so we are good to go. Let me just check that my sound is working. Okay, looks like sound is working. Okay, awesome. Weekly contest will start in about 15 minutes. Welcome everybody who's in the channel. Let me pull that up, see who's around. I see 2 people around. Alright. I see 2 people around. Right. Hello everybody. 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 Alright. I see 2 people around. Right. Hello everybody. Alright. I see 2 people around. Right. Hello everybody. Alright. I see 2 people around. Right. Hello everybody. Alright. I see 2 people around. Right. Hello everybody. Alright. I see 2 people around. Right. Hello everybody. Alright. I see 2 people around. Right. Hello everybody. Alright. I see 2 people around. Right. Hello everybody. Alright. I see 2 people around. Right. Hello everybody. Alright. I see 2 people around. Right. Hello everybody. Alright. I see 2 people around. Right. Hello everybody. Alright, so before the contest starts, we have around 13 minutes, so let's take a look at what the weekly question is. So let's take a look at what, let's see if you can help that out. Let's take a look at what, let's see if you can help that out. Let's take a look at what, let's see if you can help that out. Let's take a look at what, let's see if you can help that out. Let's take a look at what, let's see if you can help that out. Let's take a look at what, let's see if you can help that out. Let's take a look at what, let's see if you can help that out. Let's take a look at what, let's see if you can help that out. Let's take a look at what, let's see if you can help that out. Let's take a look at what, let's see if you can help that out. Let's take a look at what, let's see if you can help that out. Let's take a look at what, let's see if you can help that out. Let's take a look at what, let's see if you can help that out. Let's take a look at what, let's see if you can help that out. Let's take a look at what, let's see if you can help that out. Let's take a look at what, let's see if you can help that out. Let's take a look at what, let's see if you can help that out. Let's take a look at what, let's see if you can help that out. Let's take a look at what, let's see if you can help that out. Let's take a look at what, let's see if you can help that out. Let's take a look at what, let's see if you can help that out. Let's take a look at what, let's see if you can help that out. Let's let's see. Today's daily question is reverse string. Is it an easy question, which is always good? Reverse string. It says write a function that reverses string. Input string is given. It says write a function that reverses string. Input string is given. It says write a function that reverses string. Input string is given. It says write a function that reverses string. Input string is given. It says write a function. Oh no, something is wrong with my microphone. I'm getting massive mouse feedback. I'm getting massive mouse feedback. Okay, let me see what's going on. Okay. Okay, let me see if there's still feedback. Okay, let me see if there's still feedback. Perfect. Looks like it's fixed. Okay, let me see if there's still feedback. Perfect. Looks like it's fixed. Oh, okay, let me see if there's still feedback. Looks like it's fixed. Oh, okay, let me see if there's still feedback. Looks like it's fixed. Oh, okay, let me see if there's still feedback. Looks like it's fixed. Oh, okay, let me see if there's still feedback. Looks like it's fixed. Oh, okay, let me see if there's still feedback. Looks like it's fixed. Oh, okay, let me see if there's still feedback. Looks like it's fixed. Oh, okay, let me see if there's still feedback. Okay, I think now it should work. Okay, awesome, awesome. Alright, perfect. Okay. Yeah. Damn it. That was not great. Okay, alright. Back to the weekly contest question. Okay, so the question says write a function that reverses a string. The input string is given as an array of characters S. You must do this by modifying the input in place with O1 extra memory. O1 extra memory means that the amount of memory you use does not depend on the size of the input. So if you have an array of 100 characters, it's going to use some amount of memory. If you have an array of 10 million characters, it's going to use roughly the same amount of memory. Okay, so how do we do this? If you think about it, the most straightforward way is you have a bunch of items, 1, 2, 3, 4, 5 items. You want to reverse them, right? And you can't use any extra storage. You think about if you have a shoe rack with five boxes in them. You want to reverse, what do? The easiest way is take the guy on the left. You want to take the guy on the left, put it on the right. Put the guy on the right, put it on the left, right? So you swap these two. So you always swap left and right. And after you swap the first two, now you swap the next two. This one come here, and then this one come here, right? And you keep doing that until you reach the middle. And when you reach the middle, you're done. So that's going to be the way we're going to do this problem, this daily problem. We're going to have a left start from 0. We're going to right start from S, length of S minus 1. So right will be the guy at the end. Left will be the first item. And then while left smaller than right, S left S right. We're going to swap these two equals S right, comma S left. So for people unfamiliar with Python syntax is kind of nice. Python has a lot of tools like these. So you can actually have, you can assign two values at the same time. So in Java and C++, you have to do like, temp equals to S left, whatever. In Java, in Python, you don't actually have to do this. You can put them all on the same line. So have two things on the left and two things on the right, and then you say, okay, I'm going to swap them. And then it will be done. Okay, and after you swap this, you move the 2 pointers. You take 2 pointers, you move them one step closer to each other. Okay, and then I think this should work. Let's run it. Okay, yeah. Pretty sure this will work. This will just submit cleanly. Yeah, perfect. Beats 50% of users because I'm pretty sure. You see, this is such a nice normal distribution. This normal distribution tells me everybody has basically the same, basically the same algorithm. The only difference is some people got luckier and some people got less lucky. Yeah. So you submit a bunch of times, it's going to follow normal distribution because everybody has kind of the same algorithm. Okay, so that's pretty much it for the problem of the day, and we'll wait for another 7 minutes before the contest starts. 6.5 minutes. Let's take a look at what last week's problem was, or rather yesterday's problem was. Let's see, you can talk about that a little bit. So this is the problem from 2 days ago. So this is Thursday's problem. Hi, Kemai. How's it going? Welcome back. Welcome back. Good to see a familiar face. I'm just warming up for the contest by looking at previous daily problems. So this is, let me see what this is. Given an integer array nums in which two elements appear exactly once and all other appearances appear twice. Okay, this is a pretty interesting problem. This is a pretty interesting problem. This problem I think I remember I used. Basically, you do a XOR. You XOR all the numbers together. You use basically a prefix sum idea, but you XOR them together. I think I finished this. Wait, where are my submissions? Yeah, so I had a submission like this. Oh wow, that's pretty good. Beats 37.6. Yeah. Today, LeetCode added a warning section because from last few weeks, mass submission was done. You mean like cheating? Is that what you're talking about? I know there's that cheating has been a problem for a while. Let me see, is there a warning? Warning against cheating. Contest violation. Any contest will be replied without prior warning and will not be waived for any reason. So, which is why we are going to make sure there's no sharing of code here. Do not share code. If you share code, that is considered cheating and will get caught, right? So I'm going to be very light on the hints. I'm only give you very tangential hints. Mostly I'm just going to explain to you what the question is asking. You have to find the solution yourself. And that definitely don't share code with anybody. Because if you share code, that's the easiest way for LeetCode to detect cheating. Yeah, that's the absolute easiest. Actually, I should screenshot this and then put it in my chat. Hi, you. Good going, good going. I like your username, you. That's kind of fanciful. Okay, let me see. What other questions? What other stuff can we take a look at? So the other thing that I think a lot of people do is they use ChatGPT to answer the questions. So which is kind of interesting because ChatGPT doesn't always give you the right answers. ChatGPT is really good for things that, at least now, generative AI is good for things that don't have so-called correct solutions. So you say, write me a poem or draw me a picture. ChatGPT is really good. There's no one correct solution. You just have to be close enough. But if you ask it to do things like play chess or write a program, now it's becoming better at writing programs, but it's still not that great for a lot of larger programs. And also, LeetCode contest questions are nebulous enough that sometimes ChatGPT doesn't really work very well. Can you explain the ranking system in LeetCode? Like we have to appear every question once. So ranking in LeetCode. That's a great question. I don't actually know what the ranking LeetCode ranking system is. Let me look at it quite quickly. So basically, your ranking is based on how many questions you solve. Is based on two things. One is how many questions you solved, and it's also based on what is the time you submitted the last question. Yeah, so this person presumably took 8 minutes. Yeah, but I don't think that's correct. Yeah, so he took 1 hour and 7 minutes. Oh, I took 1 hour and 7 minutes. So this person took 8 minutes to finish all 4 questions. That's why his score is 8 minutes. So he got 18 points and his score is 8 minutes. I also have 18 points, but my score is 1 hour plus because that's how long I took to finish 4 questions. Yeah, I don't actually know exactly how the ranking system works. And to be honest, I don't, I said many times, I don't really care about ranking. At the end of the day, the most important thing is making sure that you learn something, you become a better programmer. What your actual rank is, is not worth very much. Even if you win every contest, every single time, it will not earn you a single dollar. There's no prize. The real prize, the only prize, is getting better. It's taking so long to load. Come on. Alright, contest has started. Good luck, everybody. So it's not loading. My screen is not loading. Oh my god. Yeah. Okay. Good luck, everybody. If you have questions, ask in the chat. Once again, I do all my work off screen because we don't want to copy answers, right? We don't want to share code, right? We don't want to get caught for cheating, right? So we don't share code here. Yeah, and that's not how you learn anyway. So I do all my answers off screen, but make sure you ask questions if you need them. All right. Yeah, LeetCode. Okay, now it's working. I hope it's working for everybody. It's working for me now. First ever contest. Yeah. Oh, now it's not working for me also. Damn it. Okay, now my page also got stuck. God damn it. Personal contact, tell them website is not working. I'm pretty sure they know the website is not working. They are probably trying to fix it. My guess, honestly, is that my personal guess is somebody is trying to DDoS LeetCode. I'll try to attack LeetCode's website somehow. Because my experience, I've been streaming for 3 months. I've done every contest for the last 3 months. Only in the past few weeks, the website started being slow. Before that, it was fine. So I'm guessing somebody's either trying to cheat by giving themselves a time advantage, or somebody's trying to DDoS LeetCode somehow. Yeah. So it's not working. LeetCode China is working. Ah, interesting. But LeetCode China, I don't know. Do they have the same questions? Wait, LeetCode China. Do they have the same questions? Do you know? Okay. Huh. Yeah, LeetCode is down. Well, you solved the question. I also solved the question and not submitting. You and I both. Yeah, will they cancel contest? I hope not. They better fix it soon. Hey, come on, LeetCode. LeetCode.com. So LeetCode.com is the one that's causing problems. Cloudflare is fine. So probably not DDoS. I don't know much about it. So DDoS would probably, in theory, get caught here by the CDN, the content distributor. Can they make Pranav Ja? By the way, how are you, Alex? Thank you. Okay, first of all, thank you for asking. Usually people ask how to do questions. Nobody do ask how is Alex. So I appreciate it. I'm fine, Pranav. I hope you are too. Yeah, Cloudflare's job is basically to deal with DDoS, among other things. Okay, it's back. So the contest is... Oh, is it back? Nope. Maybe it's back. Yeah, no, still not back. Still buffering. Haha, I'm also fine. Nice to hear that, Pranav. Yeah, so it says it's Fury. Sorry, it says it's yeah, Fury Nick. It says it's probably server side issue. Is it back? Let's see. Maybe it's back for some people. It's definitely not back for me. I'm still trying to submit. Yeah. Sorry, guys. Actually, I don't know why I'm apologizing on LeetCode's behalf. You guys should get angry at LeetCode. We'll be back. Oh, we're down for maintenance. Oh my god. Huh. Yeah, I'm curious. Let me try something. Oh, the whole LeetCode is down. So that doesn't even work. For me, it's still buffering. Yeah. RIP today's contest. It's been 10 minutes. So I don't know what they're gonna do. Because normally those people who win the contest, they finish in 10 minutes. Can I go back to sleep? What, it's 8 o'clock, right? It's 8:30 in the morning. It's very early. Yeah. Is it up? It's very early for you guys. Well, it's very late for me. It's like almost 11 o'clock at night. It's 11 p.m. for me. So I also want to go to sleep. Okay, cool. Now it's working. Looks like it's working. Alright, guys. Let's do this. Nope. Still not working. Let me see if I can get it to work. Fury Nick, I want to ask if I'm around 1700 and sometime I didn't do well and only solved 2 questions and minus 20 rating. I have no idea. So I actually don't look at my rank. I don't know what my rank is. It's probably about 1800. But you know, hey, wow, some people managed to get it to work. You see, 9 people finish. What is this? All right, let's start cracking. All right, guys, looks like we're back. The show is on. So let's start cracking. Okay. All right. You wake up 7:30 for contest. Yeah. Sorry, Rohan Sharma. It sucks. Okay, count days without meetings. Total number of days. Employees are ready for work, but no meetings are scheduled. Oh, interesting. Okay, cool. Huh. Will this be unrated? I don't know. Why is this happening? I don't know. Because LeetCode sucks. I'm pretty sure somebody is DDoSing LeetCode. That's my guess. I'm pretty sure this is a malicious attack and not because of some kind of natural capacity overload. So LeetCode LeetCode needs to get his shit together. Sorry. Okay. Can you explain question 1? Sure, I'll explain question 1. But again, we're trying this new thing where we're not over-explaining. We're not over-explaining. We're only explaining a little bit. All right. So minimum number of chairs in the waiting room. And besides, reading the question is an important engineering skill. So I'm going to let you guys try and practice reading question. Okay, you're given a string S. Simulate events at each second I. So if SI is E, it means somebody come in and sit on a chair. If SI equals L, somebody leaves the living room taking up a chair, right? So at the beginning, you don't have anybody. Let's say in this one. This one means somebody comes in, another person comes in, another person comes in, and then they keep coming in. Everybody enter, nobody leaves. And they enter 7 times. So how many chairs do you need? There's maximum of 7 people in the room at one time, right? So you need 7 chairs. Second one, ELE. So one person enter, next person leaves, so he goes away. The maximum is 1, right? The maximum is 1. So now, third one, another enter, and then he leaves again. And then now, 2 people enter, and now the maximum is 2, and then 1 person leaves. So the maximum number of people in the room at any one time is 2. So that's why the answer is 2. So that's what you need to simulate. So basically what you need to do is essentially to write a program that simulates this behavior. Yeah, I hope that was helpful for question 1. I don't think it's too difficult, so I'm going to let you think about it a little bit. I think that should be enough to help you get started. Nice, question 1 done. Good job. Alrighty. Can you please provide us with a solution? No. So we're not providing solution here. Once again, I will refer you to the LeetCode warning. yeah, don't warning against cheating. So they are taking a very strong stance against cheating. We will not provide solutions here. We will also not share any sort of code, in fact. Wait, hang on, I got wrong answer for question 2. That's so funny. Something is wrong. Yeah, so sorry, we can't provide any solutions, but give it a try. If you get stuck, just ask, and I'll do my best to help. Smallest non-star character. Delete the leftmost star. Also not the rank 2. I don't know if your rank get updated in real time. Code with Simran. Yeah, that's a good question. You can try. But once again, I genuinely think that, I wouldn't worry too much about the rank. As long as you learn something, you get better at programming. That's the real takeaway. Because you can win as many contests as you want. Not gonna do a thing for you. But you get better, then you can potentially get a really good job and make a lot of money. Smallest non-star character to his left is so small question. Interesting. Lexicographically smallest resulting string after removing all the star characters. A A B A A. Should delete one of the A characters with star. Maybe A star. This is kind of confusing. So question 3. The explanation is kind of confusing. Let me know if you want me to explain what it's doing. Question 1, no, you don't need a prefix sum. You don't need anything special. Question 1 is pretty straightforward. Just do exactly as they tell you. Count how many people come in. So keep track of how many people come in and how many people exit. And at any point, just track what's the largest number of people you've seen in the room at any one time. So question 1, you don't need any prefix sum or anything like that. Yeah, don't think about solution. Just look at a question and try to solve it from there. Yeah. Classic theme for the new contest. I don't know what that is. Classic theme for new contest. Let me go through question 2 real quick. Yeah. So question 2 is count days without meetings. Okay, you're given, and question 3 I'll explain later. You're given a positive integer days, represent the total number of days an employee is available for work, starting from day 1. You're also given a 2-dimensional meeting, array meeting of size n, where meeting I equals to start I, end I. Okay, this is the start of and end of the meeting. So for instance here, what does this mean? This is your day, right? 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, cool. So this is your time, right? This is your day. Okay? A days is 10 means there's total of 10 days. Okay? And then meetings 5 to 7 means that 5, 6, 7, 7, 8, 9. 5, 6, 7, meeting. 1, 3 means that 1, 2, 3, meeting. 9, 10 means that 9 and 10, meeting. Okay? So what are the times with no meeting? This one, this one. Total of 2. So there are 2 days without meeting. So that's what question 2 is asking for. So you take the days is the number of days, total number of days in your timeline. Meetings tell you which of these days are blocked out for meetings. So 5, 7 means that 5, 6, and 7 is inclusive on both sides. 5, 6, and 7 are all blocked out for meetings. And 1, 2, 3, and 9, 10, so on and so forth. Okay, I hope that's helpful. When you submit for question 2, you get unknown error. Yeah, I can tell you that. That's, yeah, I don't know what the unknown error is. Sometimes I get that. Sometimes I find that unknown error sometimes is not your fault. You just rerun it a bunch of times and it's going to work. Okay. So, for question 3, you're given a string S. It may contain any number of star characters. Your task is to remove all star characters. So the idea is, for instance, here you have A, B, A, star. So the idea is whenever you see a star, you can remove a character to its left. Any of these characters to its left. So you can remove this one, or you can remove this one, or you can remove this one, or you can remove this one. It's up to you, right? Any of these characters are up for grabs. But it must be the smallest characters, the smallest non-star character. The smallest character. So smallest means, you know, A is smaller than B. It's lexicographically smaller. Okay? And once you've removed that character, you want to keep doing this for all the stars. And then once you're done with that, you should have the smallest string that you can get. Right? So here, let's say A, B, A. If you have a star, it means that you can remove A, B, or A. You can remove one thing, right? So obviously you think the first thing that comes to your brain is, hey, what if I remove B? Then I get A. That's the lexicographically smallest, right? Well, ideally you like to do that, but you can't. Because the rule is you have to remove the smallest non-star, which means you can remove one of the A's. Which A do you remove? You remove this A, you get ABA. This A, you also get ABA. This A, you get AB. So this is smaller. Aha. Do you see the pattern here? So you see the pattern here, right? So, well, here's my question to you again. When you see a star, what should you remove? Which character should you remove? So think about it a little bit. Think about it a little bit. You have to remove the lexicographically smallest character. Well, which one should you remove? Yeah, should it be the one on the left or the one on the right? So think about it a little bit yourself. We'll come back to it. Okay, so Vikas, I'm going to ask you not to spam. Yeah, so not to spam. So don't think in terms of like stack or queue, or don't think of that first. Read the question first, understand what it's asking, and then formulate the strategy. Because if you do that, if you come with, oh, you know, I have to use dynamic programming for this, well, the first thing is you are just guessing, right? You're just guessing. You don't know what you're actually doing. So second thing is, most programming problems you see in real life are not like these LeetCode problems with well-defined classical solutions. So you have to actually think about what technique you want to use to tailor to your solution. Yeah, so don't think about the answer first. Think about the question, understand the question, and then try and figure out what you're supposed to do there. Question 2 getting TLE. Let me see. So question 2 getting TLE. I'm going to give you a hint. My hint is I guess it depends on what you're doing. So notice that the days is very long. So if you have a loop that is like for I is 1 to the days, this will not work because your days is 10 to the power 9. So this is too big. Instead, what you need to do is to go through the meetings. So my hint is this. I'm just going to write a hint there. My hint is to sort your meetings. Okay? Think about how you sort your meetings. What do you want to sort it by? And how does that help you? So do not do this. Don't do for I is 1 to days. This is too slow. So instead, you should sort your meetings in some way. So I guess that's my hint to you. Let me know if that's helpful. Okay, I got memory exceeded instead. Ha! Still question 2? Fury, Nick, are you stuck on question 2? Question 2, Q, question 2, segment 3. That's a good guess. But you don't actually need a segment 3. You don't need a segment 3. Lord Voldemort solved the first 3 with ease. Let's see the 4th one. Yes, good job. Yeah, you're faster than me. I'm still working on question 3. But then again, I also have to explain. I have to talk and explain at the same time. Sorting works. Yep, nice, good job. Yeah. So some kind of sort, that's my hint, right? We're not gonna give answers here. We're just gonna give, we're like this stream is about people coming and working on this together as friends, but we're not gonna give any answers. So don't paste any code, okay? For those of you who got it, don't put any code in the chat. Because LeetCode is pretty serious about their cheating policy. Yeah, so Fury, Nick, yes, the meeting can overlap. So what do you do if you sort them, right? You sort them by their start time. What happens when it overlaps? So you're on the right track. Think about it a little bit. Okay, let me see. Question 3, approach. Hint of 3. Hint of 3. Give me a second. Ah, shit. LeetCode is still acting up for me for some reason. Okay. So hint of 3. And look. Guys, the other thing is, before you ask for hints, try it out first, okay? So I have no real way of checking, verifying this, but you should definitely try it out first. Yeah, I'm still having problems submitting. Okay, so 3. You're given a string S. It contains any number of characters S. Okay. Your job is to remove all the star characters. Okay. So just now we talked about A, B, A, star, right? When you see a star, you get to remove something. Which one do you remove? You have to remove smallest char. And then 2. Do you remove the leftmost or the rightmost? Okay? Do you remove the leftmost or rightmost? You remove an A. You cannot remove the B because you have to remove a smallest. Because you want it to be lexicographically smallest, you want to remove the rightmost. Right? You want to remove the rightmost. So how do you do that? So one way you can do it is every time you see a star, you go do another for loop. Start from beginning and you search for the smallest A that's on the right. That's not a good way to do it. That is very slow. So instead, you can use some kind of queue to help you. Right? Because this allows you to keep track of small things. So that's my hint. Use some kind of queue to help you. Let's see if that's enough to lead you to success. Okay. Find subarray with bitwise n closest to k. You're given an array nums. You're given an array nums and integer k. You need to find a subarray of nums such that the absolute difference between k and the bitwise n. Oh my god. Bitwise n of the subarray elements is as small as possible. Return the smallest value of the absolute difference. Okay, interesting. Q2 getting TLE is sorting. Okay, so Q2. So if you sort, you should not have some kind of TLE. Make sure that your for loop only goes through each meeting once. So you think about it. If somebody tells you, oh, I have meeting from 1 o'clock to 2 o'clock, and then 4 o'clock to 6 o'clock, and then 5 o'clock to 7 o'clock, how do you find when this person is free? You go through all his meetings one by one, right? The first one, 1 o'clock to 3 o'clock, okay? You're done at 3. Then you check the next one. Next one starts at 5. Oh, you were done at 3, start at 5. Well, I guess you are free at 4 o'clock. So if you go through them, you should be able to do not get the TLE. But if you're still having trouble with that, don't worry. Let me yeah, if you're still having problem with that, I'll go through it at the end. I'll go through it at the end of the contest. Hang on tight. Or at least let me finish question 4 first. If I finish question 4 at some time, we can talk about it. Because I'm a little bit behind. I'm still working on question 4. Yeah, I'm gonna keep the screen on. I'm gonna keep the screen on question 2, in case that's helpful. That's still helpful to anyone. Hopefully that is. Again, if you're stuck on question 2, don't worry. Hold on to your hats. I'll try to get back to you. I'll try to get back to you when I can. Let me try to get back to you at the end of the contest. Yeah, because I don't want to give out answers, right? I don't want to give out answers. And I feel like, you know, the hint sort the meetings and then go through the meetings one by one is as much as I'm able to. Okay. I think I have a plan for question 4. But I'm not sure. I think I have a plan. The min char in question 3. Okay. The min char. Yeah. Yeah, I'll go through that. So that the hint is use some kind of heap. Yeah, use some kind of priority queue to help you. But if that's not enough of a hint, I can go through it later. Okay. Ah, you haven't studied priority queue? Don't worry. We'll actually, you know what? I will explain briefly later what priority queues are. Yeah. Hints for question 4. Think about it first. Don't ask me for hints first. Think about it. Think about it yourself. And then write something in the chat. So I'm also working on question 4. I think I have a strategy, but I'm still working on it. So since I'm still working on it myself, it means that it's kind of tough. So I want you guys to think about it first. Let me see if I can give a hint of some kind. So the way I think about it is you want to think of them as binary numbers. You want to think of them as binary numbers. Yeah. Yeah. I'm also trying to figure it out. I think like for question 4, the way I think about it is some kind of sliding window problem. And the idea is it's not easy to find the absolute value. But I think what you can do is you can keep track of the big and the small. You wanna keep track of for the sliding window, you wanna keep track of the biggest number smaller than k, and the smallest number bigger than k. And bear in mind that every number you yeah, bear in mind that every time you move the sliding window, how do I say this? Yeah, the larger your window, the bigger the smaller the n will be. Yeah, because it's a bitwise end. Yeah, so Cam, I think of the problem. Try to figure out your own solution first. Don't ask for hints right away. Just try and figure out. Think about it on your own first. Yeah, because the question 4 is supposed to be hard, right? So think about it on your own first. And then we can discuss later. I'm also trying to figure it out. So Lord Voldemort, have you solved question 4? Yeah, it's kind of tough. It is. Yeah. So for manas. Yeah, for manas, time complexity of ND. Yeah, so you cannot have ND. D is very slow. So D is a very large number. So question 3 hints is on the board. So Anish Rusia. So if you understand the question, every time you see a star, you have to find a small you have to find basically the smallest character, and you need to find the smallest character that's, do you want to get it from as far left as possible or as far as right as possible? So in this example, AABA star, you can delete one of the A's, right? Which A do you want to delete? Either the one on the left or the one on the right, right? It's one or two. So try it out yourself. Which one do you want to delete? And once you figure that logic out, you can use some kind of priority queue to help you make your program faster. So Cam I, today LeetCode gives us 10 minutes of extension due to site down. Yeah, they owe us 10 minutes. Come on. They better. So that means we should all try to finish more questions then. Yeah, I'm also kind of stumped on question 4. Yeah, so the strategy I thought would work, as I wrote it out, probably doesn't work. So I'm kind of stumped on question 4 also. Because end is sort of not is kind of destructive. If you end two things, you end a bunch of things together, you cannot undo the end. The bitwise end is very difficult to undo. Oh, actually, it's possible to undo the bitwise end. Wait a second. It is possible to undo a bitwise end. Oh, actually, it is possible to undo a bitwise end. Huh, interesting. Which question am I doing now? I'm working on question 4. So Vikas Singh, I'm gonna ask you again not to spam. Just relax and work on it first. Don't panic. You still have a lot of time. Yeah. So let me. Yeah. The other thing about spamming is I can see the earlier ones. Hints value decreases is sub array size. Yeah. So it's monotonically decreasing. You can actually revert the end, I think. So that's where I'm trying to. What's the fixed size of the window? I'm thinking, when do we shrink it? Yeah. So Peaky Blinder, do you manage to finish question 4? If you can, then congratulations. Yeah. And you can actually, you can in fact revert the end. It's possible. So that's actually what I'm trying to do now. Oh, you've done 4. Very nice. Yeah. If sorry, Unfortunately, that means people will come and ask you for answer. So I am going to ask you, so first of all, congratulations. But I am going to ask you not to give any answers in this chat. Do not share your code here or elsewhere, even if people ask you. Because LeetCode is very, they are very, they are very strict about their cheating policy. So do not do that. But feel free to give people hints if you want, or not. You're not obligated to do anything really. But I'm gonna ask again. Nobody asked for code. Nobody asked for answers. Oh, you saw 4 with 2 penalties. Very nice. Yeah, thank you. Yeah, congratulations, Lord Voldemort. Yeah, very nice, very nice. Yeah, I'm still trying to figure out 4th. So you guys are ahead of me. Very well done. One 1101101 9049. Solved all 4 in 47 minutes. Very nice. Yeah, I can't figure out question 4 for some reason. Huh. 111011. Question 4 hint. Yeah, I can't get question 4 either. So Himanshu and Peaky Blinders, very well done. You guys are the heroes of today. I have a bug in my question 4 for some reason. Yeah, don't paste question 4 here. Definitely don't put any code here. So Glenn M, if you want answers, just wait another 10-ish minutes. Once the contest is over, we can start talking about answers. Because at the end of the day, it's still a contest, right? So WebSlick, I'm going to ask you to stop spamming. Yeah. Oh, the question? Oh, okay. Yeah, I can show the question on the screen. Sorry, I did not. I was misunderstanding you. Yeah. So the question is this. I think you can see it on the screen. It's a bit better than somebody copy pasting. Huh. Keep getting these weird off by 1 errors. I think I'm pretty close, but somehow I'm not getting it. So K is 69. Hopefully they really give us 10 more minutes. 1000101. Oh, you know what? I can do this. Try taking index 1 left, 1 right. Yeah. That's what I'm doing. TLE. Yeah, I don't think I can finish this, unfortunately. Unless some miracle happens. So sounds like your solution is also ON square, right? Theoretically ON square. It sounds like Peaky Blinder. Your solution is also ON square. Because my solution is also ON square. I feel like it might be similar to yours. But it's TLE. Damn it. It's n log n times 30. Oh, so you use the bitwise array. Huh, interesting. Wait, n log n times 30. Yeah, let me, okay. Is the contest over? Let me just check. Or do we actually get 10 more minutes? Very nicely done. It sounds like the contest is ended. Okay, all right. All right, it's been a struggle, boys and girls. It's been a struggle, but officially the contest has ended. So the struggle is over. I have failed in my quest for question 4, but it sounds like you guys managed to do it. Let me take a swig of water. Let me just read through. You know what? Let me read through the chat first for question 4, and then I'm going to go through all 3 questions. And if I understand, what you guys did for question 4, so now the roles are reversed. Then we can go through the answer for. I'll have answer for all 4 questions on record. Let me read this carefully first. But let me take a swig of water. You just solve question 4 by doing 2 loops. I also did 2 loops. But my 2 loops got TLE. God damn it. You add new numbers to total n, and I start to use 2 loops to reverse. What do you mean by remove previous? You have to implement the revert function. Oh, so you actually implement the revert function. So the revert function, do you just count how many times? Do you do the binary and you count how many times there's a 1 in each place? Is that how you did the revert function? I don't quite understand your revert function. You use a binary array. A binary array? Huh, interesting. Not sure if I understand. So what I was thinking is I have an array that count how many times each number was a 1. So let's say the first number is 0, 0, 1. This will be 1, 0, 0, 0, 0. Second number is 1, 0, 0, 1. Then this number will be 2. And then this number will be 1. So this was the array that I had in mind. Then if the third one is 1, 0, 0, 1, then this number will be 3, and then this one will be 2. So keeping track of how many times a 1 has appeared in each place actually allows me to do revert. So at first I was going down the revert path, and then I got stuck. I didn't have time to do it properly. Yeah, that's the way you did it with the revert? Okay. Cool. Yeah. Nice. Very well done. Damn, I should have followed my instinct. So I also tried the revert, but then I had a few bugs in the revert, and I thought, oh, maybe I shouldn't revert. Yeah. Yeah, so I thought, yeah, at first I also wanted to do the revert. So it looks like revert is correct. So okay. So what do you do after the revert? I guess what do you do after revert? Do you use like some kind of sliding window? If you have revert, then you can use sliding window, right? You can have like 0, 1, 0, 1, 1, 1, 1, 0, 0, 0, whatever. Then you can do like sliding window. And then if you see that the number is too big, you just go to the left or to the right. Yeah. Okay, and I'm curious about how you wrote it. I guess Chem I is our investigator. If you tell him your username, he's going to investigate. Yeah, you reduce your window size. Yeah. You reduce like the binary end of the window, because when you do a bitwise AND, the result is monotonically decreasing. It always goes down. It never goes up. Yeah. So what happens when you revert? So here's my question to you. So you have this tree, right? This is for starting from index 0. What happens when you start from index 1? So you have to your window have to get rid of this. And then how do you know whether to go up or not? Add the new function, add to the total now. Yeah, but I guess my question is, when you shift your window, your sliding window one step to the right, you revert the previous one, right? And then how do you know how many to add? Yeah. I guess you might need to... Oh, let me see. Huh, interesting. Oh, okay. You just add one and check it right away. I see. Oh, maybe that works. Yeah. Okay. Cool. Yeah. Well, thanks for sharing. That's pretty smart way of doing things. Okay. Let me just go to the beginning, and then we'll do a discussion of all 4 questions, because I know people are stuck on question 2 and question 3, right? So we'll go through all 4 questions. I hope everybody who attended the contest got the score that you like, but also more importantly that you think you deserved. I think that LeetCode sort of cheated us of a few minutes at the beginning. That's not good. But it is what it is. I managed to finish 3, which is not great. I spent more than 1 hour on the 4th one and still didn't manage to get it. But it is what it is. Okay, let me bring up my script, which I have to say because some people, some viewers are watching this from the VOD, so I need to say something so I can cut so that this part becomes the start of my video. It is weird. YouTube is a weird place. All right. We are discussing answers for LeetCode Weekly Contest 400. Jump to specific questions using timestamps in the video description. Please check out the rest of my channel if you enjoy LeetCode content. Like and subscribe to stay up to date on new videos. Okay, guys. And while you guys are still here, shameless plug. If you enjoy what I do, if you like the contest, if you enjoy my work at all, throw me a like and subscribe. It helps me so much to keep my stuff going. And check out the rest of my videos. That's the part that is slightly more important for YouTubers. Videos are a little bit more important than live streams. For my username, I don't know what's my username. My username is my username is just Alex does LeetCode. Yeah, just Alex does LeetCode with dashes in between. It's just Alex does LeetCode with dashes in between. You can see my ranking is not very good, unfortunately. But it is what it is. Alright, cool. Let's go through the answers for all the 4 questions. Rankings are not super important, but rankings are temporary, but learning is eternal. So, question number 1. Minimum number of chairs in a waiting room. Let's read through the questions first. You are given a string S, simulate events at each second I. So you're given a string S. The string S can contain E or L. E means somebody comes into the room and sit on a chair. L means somebody exit the room and free up the chair. So your job is, given the string, count what is the minimum number of chairs needed so that everybody can sit. So this is basically the number of the maximum number of people who's in the room at any one time. Right? So this is not super hard. Basically, you just do a for loop that says when you enter, add 1. When you exit, minus 1. That will count how many people are there in the room. So you have for loop. Chairs is the number of chairs, the number of people in the room. So when somebody enters, your chair equals chair plus 1. When somebody leaves, your chair equals chair minus 1. And then at any time, you count the maximum number of chairs, the maximum number of people in this room. Right? So that will be the number of chairs that you need. If there's at most 5 people in the room at one time, you're going to need 5 chairs. So this chairs variable, it will keep track of how many people there are currently in the room. And MX is the maximum number of people you've seen so far. So that's all there is to question 1. Alright, so question number 2, count days without meetings. Okay, this is a fun one. Count days without meetings. You are given a positive integer days, representing the total number of days an employee is available for work. You're also given a 2D array, meetings of size n. So the array represents the meetings, and then the days number tell you how many days are there total. So for instance, in this example, there are 10 days. So you have a number line from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 8, 9, 10. Okay. And then the meetings will tell you which plots are blocked out. So 5 to 7 is blocked out. 1 to 3 is blocked off. And then 9 to 10 is blocked off. Okay. And your job is to count how many free slots there are. Well, if you just go day 1 to day n or whatever, like somebody in the chat did, this is very slow. As you can see, there are 10 to the power 9 days. You are not going to succeed. You will get ONK, which is a huge number. So instead, what you want to do is you want to sort the meetings. You think about how somebody will plan his meeting, right? You ask somebody, when are you free? Well, he says, I'm busy from 1 to 3. And then 5 to 6, I'm busy again. 5 to 7, I'm busy again. Well, you know he's free at 4. So you basically go through all the meetings. You sort them by their start. You don't care about the end. You sort all the meetings by their start. Alright? And then you have this thing. You have this counter called your current time. So your current starts at 0. And then you look at the first meeting, right? First meeting is from 1 o'clock to 3 o'clock. Means that 1 o'clock to 3 o'clock is all booked up. So you moved your current to the end of the meeting, which is 3 o'clock. And then now you go to the second one. The second meeting starts at 5. Okay? Since your current is at 3, you know there's a gap. Because your current is 3, you know there's a gap. Right? Between 3 and 5. So you can do this thing here. Count equals to start minus current minus 1. So this is the start of the new meeting. The start of new meeting minus the current time will be how much free time you have. And then after you do this, you set current to the end of the current meeting, the max of the current and current meeting. So this will work when, for instance, there's an overlap. So for instance, there's another meeting from 3 to 5. Okay? Then your new start will be at 3. your current will also be at 3. Then you realize, oh, the meeting continuous. You have back-to-back meetings, so your current has to jump to 5. So this is the part that makes this happen. So if you do this, you reach the end, and then last thing you need to do is, if your last meeting ends before the end of the timeline, then all the time that you have, if the last meeting ends, your current, which is the end of your last meeting, is smaller than number of days, then your count equals to days minus current. So all the time you have from the end of the last meeting to the end of all your days is your free time. Yep. So that's how you do question 2. So if you do this correctly, it should be I guess n, where n is the number of meetings, and you don't care about days. Okay. Okay, there's no question in the chat. Okay. Hold on. Okay, solution 3. This is the one that everybody is asking for. All right, so lexicographically minimum string after removing stars. Question 3. Let's figure out what it's trying to say first. You are given a string S. It may contain any number of star characters. Your task is to remove all the star characters. Whenever there's a star, do the following operation. Start from the leftmost star, and then delete the smallest non-star character to its left. If there are several smallest characters, you can delete any of them. And then you have to return the lexicographically smallest resulting string. Lexicographically smallest means where it appears in the dictionary. Okay, it's just where it appears in the dictionary, that's all. So in the first example, you have A, B, A, star. Okay, because there's a star, you can delete one of these. Which one will you delete? Well, the first rule is it has to be the smallest non-star character, which means you have to pick one of the A's. Pick one of the A's to delete. You cannot delete the B. You would like to delete the B, because deleting the B makes you the lexicographically smaller. You want to keep the small characters, right? You want this string to be as small as possible. You want to keep the small characters. Well, if you have to delete the A, which one do you delete? Do you delete the one on the left or on the right? Well, it turns out that you should delete the one on the right. You should always delete the rightmost one. Why? Because if you delete, you're deleting the smallest character. And if you want your resulting string to be lexicographically small, you want to keep the small characters on the left. So for instance, if you delete this one on the right, you get AAB. You delete the earlier one, if you delete the second one, you get ABA. And AAB is smaller than ABA. So deleting the last smallest character is the right thing to do. Okay, now that you know the strategy is every time you see a star, delete the right smallest character. What's the most efficient way to implement it? Well, one way you can do it is whenever you see a star, you go through the whole list, your whole array, until the point where you see the star. Find out what's the smallest character and then delete that. That's not going to be fun. In fact, that's a horrible way to do things. We have a better way of doing it by using this thing known as a priority queue. In Python, it's called a heap. In Java, I think it's called a priority queue in Java. Actually, I think Java is also called heap. I'm not sure. I have to look it up. But they are basically the same thing. The thing, what a heap is a very efficient way of storing a bunch of things so that you can find the smallest thing at any one time. It's a tree. Internally, it's stored as a tree. So the thing about the heap is you can ask it one question only, which is give me the smallest thing. You cannot ask it for anything else. If you ask for anything else, it's going to be slow. But you can say, give me the smallest thing, and it'll give you the answer very fast in all one time. So that's what a heap does. So basically, the strategy here is you want to keep all these guys on the heap. And then, whenever you see a star, you remove the thing that is the sort of best thing to remove. And so, how do you determine the best thing to remove? Well, there's two criteria. One is what is the character, and two is what is position. So basically, what I keep in my heap is the following. As I go along, I'm going to keep a pair of the character and its index. Okay? And I'm going to define the sorting function such that the index is larger. The larger the index, the smaller the value. So the first A will become this. The second A becomes A1. It goes in front because the magic of the heap keeps it sorted. B becomes B2, and then this A becomes A3. Okay, so the heap keeps this thing sorted. So when you see a star, all you have to do is to take the first one, A3. I have to delete the letter A at index 3. If I see one more star after this, then I will simply delete the next one, which is A1, the A at 1. Oops. So I'm going to delete the smallest element furthest to the right. That's the rule. Okay, so how does it look like in code? Basically, to make things a little bit easier for me, instead of modifying the string, because modifying string is very expensive, I keep this array called deleted. So deleted is false at the beginning. And then at any one time, if si is not a star, then I'll just heap push. So I heap push si with the character itself, and minus i. This way, I basically want to sort the indexes by reverse order. I want the largest index to be smaller, so I do minus I as a trick. If si is a star, then I'll say remove si. I don't need si, and I can also remove minus index of this heap. So I find the first thing in the heap, I pop it. Let's say in this case is A3. I'm going to say I don't need the A. I don't care about it anymore. I just need the index. I'm going to remove the character at 3. So this is what this line is doing. So I basically find the most eligible character to pop, and then I pop to remove, and then I remove. I said remove at the index to true, and then at the end all I have to do is go through. If this is not removed, then I append. If it is removed, I skip, and then I join them up. And this will give you the working solution for question number 3. Let me see. Yeah, priority queue in Java. Okay, got it. Yeah. Then, yeah. I wonder, I'm not super sure if heap and priority queue are exactly the same thing. I think they are the same thing. I think so. Not super sure. Not well, remove the rightmost thing. Yeah, you got the idea, remove the rightmost thing. Yeah, because you want the small things. You remove the smallest thing, right? And you want the small letters to be on the left. So since you have to remove the smallest letter, well, let's remove the one on the right. If you had to remove the largest letter, then you want to remove the leftmost one to keep it as small as possible. Okay, so question 4. Question 4. So I didn't manage to finish question 4. Yeah, I didn't manage to finish question 4. So I'm going to try and explain what I understand from... It's more like I had difficulty fully understanding the question description. No, don't feel bad. Look, Fury Nick. when I first read the question, I had no idea what he's talking about. It is such a confusing way to describe it, right? You're given a string, you're given star, you delete the leftmost. Like, dude, just say every time you see a star, find the smallest non-star character and then delete it. This is just very, very confusing. Yeah. So I think the trick is to read the examples. And I think this trick is true both in competitive programming questions as well as in real life. When somebody asks you to program something in real life, they are probably going to suck at explaining what they want. So you have to ask them questions. I don't know how many of them are students, but if for those of you who are software engineers, you know the horrors of working with a product manager, because many of them struggle to explain, what is it that they want, the customer wants. So you as the engineer always have to ask a lot of questions. You have to be, the adult in the room, and you really have to peel back that onion and ask for examples. That's really the best way to communicate. Okay, all right. But I should be kind to product managers. They're great. All right, so find subarray. Question 4. Find subarray with bitwise and closest to k. You're given an array nums and an integer k. You need to find a subarray of nums such that the absolute difference between k and the bitwise n of the subarray elements is small as possible. This is another example of LeetCode being really obtuse with the way it describes things. Basically, you have to find a subarray. Subarray just means contiguous, nums l ... r. So everything from it's just a contiguous subarray. You take the bitwise n of everything, and you compare with k. Yeah? So that's the basic premise of it. Okay. So, so how do you do that? And you compare to k, and you want it to be as close to k as possible. So this is kind of funky. It says k minus the bitwise n, and take the absolute value, should be minimum. So you want to have it as close as possible. So I didn't manage to finish it. I did this thing works. This is correct, but it's TLE because it's ON squared, basically. It's a little better than ON squared, but we can do better. So my understanding of how we should approach this is actually as I think you can do a sliding window. Okay? So the idea is, let's say you have 1, 2, 4, 5, 2, 1, 7, whatever, right? And your k is 3. You want to take the first one. You want to keep going until you reach a number smaller than k. And then you compare and see what is which one of these will give you the minimum distance. I think that's the basic idea. So your window, if you start at here, you have to create a window that goes all the way to a number that is smaller than k. Or actually, I think the better way is larger than k. Such that this is larger than k, and this next one is, if you take the bitwise n of these three things is larger than k, you take the bitwise n of next one is smaller than k. So the key observation is that bitwise n is monotonic. So when you end two things, it becomes smaller. It doesn't become bigger. You always get smaller and smaller. Yeah? So that's the key observation. So when you start here, you want to keep going bitwise n until you get to a number that is like just a little bit larger than k. And then you check this number, you check this other number, and you see which one of them is the minimum. Okay, now moving the window to the right. This is actually the tricky part. You know, sliding window, you want an efficient way to move the window to the right, right? And so bitwise n, there's no easy way to move the window to the right, because you need a way to revert. You need to undo this 1. So you have in your window, your first window contains the bitwise n of 1 and 2 and 4. And you need a way to get from here to 2 and 4. You sort of want to undo the 1. There's no easy way to do this. So what you have to do is you have to actually write your own method for function for undoing this bitwise n. And so it turns out the way to do this, and you actually see this in a lot of LeetCode problems, is you want to maintain a an array. Okay, let me open a new one, so I have a bit more space to explain how reverting. Change the color. Oops. Reverts an AND operation. How do you undo an AND operation? So to undo the AND operation, you actually need to keep, you can't just keep the result of the AND operation. You actually keep an array of how many times something has happened. So for instance, let's say the first number is 0, 0, 1, second number is 0, 1, 0, third one is 1, 1, 1, and the fourth one is 0, 1, 0, whatever, right? So in order to be able to undo operations, you can't just do this bitwise and is 0, 1, 0 because 0 and then 0, 0, 0 or whatever. That's not going to work. Instead, what you need to do is you need to keep an array where you count how many times that a 1 appears at each of the positions. So your beginning, your array will be 0, 0, 1. And then when you add this, it will be 0, 1, 1. Okay? And then when you add this will actually be 1, 2, 2. When you combine all these three things. So you can't do a simple bitwise AND. You have to count how many times they appear. Okay? And to convert this to a bitwise AND, all you have to do is to check. You check if any of them is equals to 3. So none of them is equal to 3, is the bitwise AND is 0, 0, 0. Because you know there are 3 numbers here. If you want to revert, let's say the first one. Then all you have to do is to change this to 1. And then the number of numbers here is now going to be 2. So this is a 2. So turning this array of bits into a bitwise AND, it will give you 0, 1, 0. So this strategy allows you to revert things. And how big is this array? Well, the length of this array depends on the largest number in the array. So in the question, you can actually see, the question you can see is nums is up to 10 to the power of 9, which means that your array, this array, is going to have length equals to 31. I think it's 30. It's either 30 or 31. I don't remember. Yeah. Okay, let me go back here. I'm a full-time engineer, so I know the pain. Yes. Yeah. Well, yeah. There's a way by using bit array. Using bit array. Wait, how do you use bit array? Yeah, I'm curious about this. Yeah. So and Peaky Blinder, I know you actually did it. I'm just theorizing. So if you have a better way of doing it, just let me know. I'd be happy. I'll be very excited to share your answer actually, because you actually did it. So you're the hero here. Okay, so let's get back to what I was talking about. So using this ability to revert, this allows you to actually do a sliding window. So when you, so again, coming back here, the goal is when you start from the start of the window, you want to find a number such that the bitwise end of these numbers in the window is larger than k, and the bitwise end of the next person, if I include one more person, is going to be smaller than k. Okay, that's the criteria for the window. So you will then check two numbers, the bitwise end of these three. You're going to check the bitwise end of these three numbers. These three numbers, compare it with k, and then bitwise end of these four numbers and compare it with k. Okay, so once you've done that, you can now move the left side of your window. So to move the left side of the window, just use the undo operation that we described before, the trick, to get this. And then now we move the right side until we reach the same condition. Maybe it's here. I don't know. I'm just guessing. Again, the condition is such that the end of the window, the bitwise end of everybody in the window is going to be larger than k. The bitwise end of everybody in the window plus one more is going to be smaller than k. Remember that bitwise end is monotonically decreasing. The further you go, the smaller it becomes. Okay? Yeah. So you do that, and then you move this one more step to the right, and then you proceed, the same. So for every window, you check the left side and the right side, because such that k minus nums is this absolute, because it wants to have a minimum of the absolute value. So you have to check both the positive minimum and the negative minimum. So you keep doing it until you reach the end, and then that's basically the sliding window. What you said is using bit array. What do you mean by, yeah, so like depends on what you mean by bit array. I think different people have different definitions. I think like the bit array in my mind is an array of bits, but it sounds like the bit array that you have is an array that counts how many occurrences there are there of each bit. Yeah, if that's what you mean by bit array, then yeah, we're describing the same thing. My rank is very bad. My rank is like 3,000 something. My rank for the contest today. My overall rank is very bad. So my rating is like 1800 plus. Yeah. Let me see, any questions? So yeah, so Kemai, sorry, let me link to, so Kemai, I'll link you to the VOD so you can watch it afterwards. I don't want to explain the same question multiple times, because other people are watching, right? But I'll send you the VOD later once the stream ends. Then you can, I mean, you can actually do it now. Just like move the time back a little bit. My username is just alex-das DOSE -LeetCode. Yeah. Any other questions? How did you guys do? It sounds like some of you guys did really well. If you honestly, if you managed to complete all 4 questions, you're doing pretty well. I feel like you should have no problems answering those technical interview questions. As for winning a competitive programming contest, that's probably that's really a separate game. I don't know how they managed to finish in 12 minutes. I have no idea how. At minute 12, my page is still not loading. So I don't know how he can finish in 12 minutes. Yeah, only 3 questions. Yeah, only 3 questions, unfortunately. Not even getting interview? Huh. Are you Peaky Blinder? Are you a student or are you working as a programmer? If you don't mind sharing. Students. Oh, well, you have time. Try internship first. Are you in India or are you in the US or somewhere else? Because I know US has a lot of internship opportunities. I'm not so sure about India. Yeah, India. I'm not sure about India whether there's many internships. I guess probably the big companies will have internships, right? The US, there's a lot of internships. There's no excuse not to try. Try everywhere. Yeah. My branch is chemistry. Ah, okay. Yeah, that's not great. Yeah. I think in the US, people don't care as much about your major. In India, I'm not sure. You're from Taiwan and the job market is challenging? Yeah. I think the job market is challenging everywhere, unfortunately. In the US, we just have a lot of tech layoffs. So last 2 years, a lot of people got laid off. I actually left my job around the same time. Even I didn't manage to get laid off. I was hoping to get laid off. I didn't, but I left voluntarily on my own. Is doing, let me see, 3 questions okay? So Sriram Rajkumar, let me tell you my very honest answer is the fact that you're here and you're trying the contest means you're already ahead of the curve. Even if you don't answer any questions, it's still fine. But as a second year student, if you can answer 3 questions, honestly, it's fine, right? Because the main thing you need to know to do well in your class and also to succeed as a junior engineer is you need to have very strong grounding in your data structure and algorithm. And these are basic algorithms and basic data structure. And you should be good enough that if you have a data structure algorithm that you've never seen before, you know how to find it on the internet. Yeah. So if you're able to answer these questions, in fact, I would go so far, I'll go one step further and say, even if you don't know how to do something like question 4, if you listen to the hints from Peaky Blinder and Doe Dragon and everybody else, and after listening to their hints, you're able to reproduce their answer, I would consider you a good programmer, right? Because you don't always have to be smart yourself. If you're good enough at programming to understand other people's cleverness and use that, you're doing fine. Yeah. They teleport humans from Mars and finish in 12 minutes. Yeah, I know. 10 minutes, we're still stuck in loading screen, you know? How is this possible? Oh my god. Okay. Well, if you have any questions, type in the chat. If not, then I think that's pretty much it for the contest. So once again, is this your no Alex dash LeetCode? Yeah. So once again, so first of all, once again, if you haven't already, please like and subscribe. Subscribe to the channel and then like the video. It does help me out a lot. You guys watching help a lot. So come back week after week. I'm really enjoy doing contests with people. If I'm on my own, if I'm not streaming, I don't feel like doing because it's not as fun, right? You get to chit chat a little bit and talk to people while doing the contest. So make sure to come on back every week. And if you come back and you learn something, then you are already a winner. Don't worry too much about your actual rank. Yeah. With that, I think it's time to sign off. Thanks a lot and see you guys next week. Bye. Oh, no code chef or code forces. Those are too gamey. I like I want to teach programming, but those are too much like puzzles rather than real programming questions. So I don't do those. Yeah. All right. Thanks a lot. Bye.